matrix multiplication, multiplying two matrices of having the order A as m cross n. For B it is r cross s. The output will be the order m cross s. Here the main condition is n and r should be equal. N and r should be equal, which means the number of columns of matrix A should be equal to the number of rows of matrix B. So coming to the properties, it doesn't follow the commutative property, which means AB is not equal to BA, and it follows associative property, AB into C is equal to A of BC, and it follows the identity matrix. So what should be multiplied to the matrix A so that the output will be the same matrix of order same n cross n. So for this identity matrix, the order should be n cross n. Matlab it should be a square matrix. Then only this property this property follows. Fourth, it's the distribution over addition property. Here A is distributed for both B and C, and here C is distributed for both A and B. Next, let's solve a question so that you'll get a better idea how the matrix multiplication takes place. Before that, just write the order of this matrix, which is 2 cross 2, which means 2 rows and 2 columns. Here 2 cross 3. Here this 2 and this 2 are same. So it means n is equal to r. So it follows the matrix multiplication. So for this, what will be the output? What will be the general output? It will be of order 2 cross 3, which means 2 rows and 3 columns. So let's write it as A11, A12, A13, which means the first row and 3 columns. Next, second row, A21, A22, A23. So how the matrix multiplication takes place? To get A11, I need to multiply the first row of first matrix with the first column of the second matrix. Here 1 and 1. First row of first matrix and first column of second matrix. So here it becomes A11 will be this multiplied by this. So it becomes 1 into 1 plus minus 2 into minus 3. It becomes 1 plus 6, which is 7. Similarly, A12, which means first row of first matrix, second column of second matrix, which is 1 into 2 plus minus 2 into 2, which is 2 minus 4, which is minus 2. Similarly, A13, it's the first row multiplied with the third column. 1 into 3 plus minus 2 into minus 1, which is 3 plus 3, 6. Similarly, follows for second row. A21, second row with first column. 2 into 1 plus 3 into minus 3, which is 2 minus 9 minus 7. A22, second row with second column. 2 2s are 4 plus 3 2s are 6. Second row with third column. 3 2s are 6 minus 3, which is 3. Hence, we can write the final answer as, just substitute these values, 7 minus 2, 6, minus 7, 10 and 3 of order 2 cross 3. So this will be the order 2 and 3. First matrix A of order 2 cross 2, and assume second matrix as B of order 2 cross 3. Then we got the output as AB, which is 2 cross 3. Now, just do the reverse. Will you get the matrix multiplication or not? It will be B 2 cross 3 and A 2 cross 2. First, it doesn't follow this condition. Here N and R are not same. So it doesn't follow the matrix multiplication. Here two matrices won't even multiply. Okay. If it doesn't follow this condition, then matrix multiplication won't take place. Matrix multiplication doesn't follow. Okay. Here two matrices are given and we need to find out AB and BA. Here, what is the order of A matrix? It is 3 cross 3. 3 rows and 3 columns. Similarly, B has order 3 cross 3. So, to find AB, can we find AB or not? Is it possible for the matrix multiplication? Yes, because here 3 and here 3 are same. Number of columns of A matrix and number of rows of B matrix are equal. So the final output will be of order 3 cross 3. This and this. Okay. Now, how to multiply? This goes with this. First row of first matrix multiply with first column of second matrix. So minus 1 and 1, minus 1 plus 1 and 0, 0 and this 0. Next this with second column. Minus 1 into 2 is minus 2 plus 1 and plus 0. Next third column. It's just minus 3 and plus 0 and plus 0. Next second row with first column. Multiply 0 and this will also become 0 and this will be 1. Next 0, it's minus 1 plus 1. Next again 0, 0, 0. Next third row with first column. 2 plus 4. Again with second column 2 plus 3 plus 4. Next with third column it becomes 6 of order 3 cross 3, which is nothing but minus 1, minus 1, minus 3, 1, 0, 0, 6, 9, 6 and 3 cross 3. So now can we find B into A? Is it possible? Again, yes, because 3 cross 3 and 3 cross 3. Again, number of columns of B matrix and number of rows of A matrix are equal. So again it becomes the same order, 3 cross 3. Now we need to multiply this first row with first column. It becomes 1, 2, 3 with minus 1, 0, 2. It becomes minus 1 plus 6. Again with second column. 1, minus 2 plus 9 with third column. It becomes 2 plus 12. Again, here second row with first column. It becomes 0, 0 and 0. Next with second row with second column. Becomes 0, minus 1 plus 0. Second row with third column. It becomes 1. Now, third row with first column. It becomes minus 1. Third row with second column. It becomes 1 minus 1. Next, third row with third column. It becomes 1 of order 3 cross 3, which is nothing but 5, 8, 14, 0, minus 1, 1, minus 1, 0, 1 of order 3 cross 3. Here, from this we can tell that AB of 3 cross 3 is not equal to BA 3 cross 3. Okay, by this we can satisfy the first property, that is it is not commutative. It is not commutative property. Next question. Two matrices are given and it says if A square is equal to B, then we need to find the value of alpha. So first we need to find out the A square. For this it becomes alpha 0, 1, 1, which is of 2 cross 2, again multiplied with the same alpha 0, 1, 1 of order 2 cross 2. So it follows matrix multiplication. The final order will also be 2 cross 2. Now just multiply first row with first column, will get alpha square, and first row with second column you will get 0. Second row with first column you will get alpha plus 1, and second row with second column you will get 1. Now just equate this A square matrix with B matrix. So we'll get as, when we equate A square with B, we'll get as alpha square is 1. This alpha square equates to this one. 0 is also equal to 0. And this alpha plus 1 equal to 5. And 1 is equal to here 1. So from this we will get alpha value as plus or minus 1. And from this we'll get alpha is 4. Now when we substitute this plus 1, minus 1 or 4 into this A square matrix, it doesn't equate to B. Let's see. If we substitute alpha as 1, then we'll get it as 1, 0, 1 plus 1 as 2 and 1, which is not equal to B. Again, substitute alpha as minus 1. You will get as 1, 0, 0 and 1, which is again not equal to B. Now substitute 4, which is again not equal to B.